I can't overstress the power of being able to solve equations. They're not only sort of important for mathematics, but they're really important in real-life applications. Let's start off by looking at a real-life application and see how solving an equation, first producing the equation, then solving it, is going to be the key to understanding a real-life issue. Let's check it out. So Chris's landscaping bill is $392. The plants cost $200, and the labor cost $48 per hour. The question is, how many hours did the landscaper work? Okay, now we have to parse this together, and it turns out this is what we sometimes refer to as a two-step equation. Now, if you think about it, the total bill is really going to equal the amount we spend on the plants, or that Chris spends on the plants, plus the amount that she spends on labor. So we've got the plant cost plus the labor cost. Now we can actually figure this out. Now the total bill, we know, is $392. So that means that we have $392 and that's going to equal, well, how much that she spent on plants, that was $200, plus how much was spent on labor. Well, it's $48 per hour, and the question is, how many hours did the landscaper work? Okay, well, this is great. Since we don't know it, it's an unknown, and so we use a letter to distinguish the fact that we don't know it yet. Okay, so what should we call it? You can call it anything you want. You can call it X, you can call it Y, you can call it W, you can call it Z. You can call it B, you can call it C. I'm going to call it H to remind me that these are actually the hours worked. But you can call it anything you want. Well, if we have the number of hours worked being H, then how much did she pay for labor? Well, we know it's $48 per hour. Per is my cue when I hear that I'm multiplying. 48 times H. Now that's the hardest part in my mind, is actually creating the equation that corresponds to all those words. So we just made the translation. Now we're going to solve. Well, solving is not a problem. I want to undo the addition of the 200, so I'll subtract 200 from both sides. And what do I see? The 200s cancel. I'm just left with 48H equals 192. To undo the multiplication of 48, I just divide both sides by 48. This simplifies to just H. So I have H equals, and I have 192 divided by 48, which is 4. And the units here are hours. And so I see that the landscaper worked for a total of 4 hours. Really important how we set up the equation and then solved it, converting all those words to actual mathematics. Now we can actually check our answer by creating a little table. So let's create a little table here and look at various scenarios. Suppose the landscaper worked for 1 hour, 2 hours, 3 hours, or 4 hours. What would be the labor charge in each case? Well, if the landscaper worked for 1 hour, it would be just $48. That would be 48 times 1, which is 48. If the landscaper worked for 2 hours, that would be 48 times 2, which would be $96. If the landscaper worked for 3 hours, that would be 48 times 3, which is 144. And if the landscaper worked for 4 hours, that would produce a bill of $192 for labor. Now, what about the plant charges for each of these hours of labor? Well, the plant charge is fixed. Doesn't make a difference how much the landscaper worked. This is always $200. Total charge, we just add up these two sets of numbers. So here I see $248. These are all units in dollars, by the way. I'll put $1 sign in front, and that carries down. Here, 96 plus 200 is 296. Here I see 344 when I add these two